Hi guys, welcome back. So as we have already talked about different kind of job profiles, let's talk about the fundamentals of machine learning that will further help you in understanding the different kind of options you have. In this video, we are going to cover different aspect of machine learning, different types of machine learning. So let's dive. Alrighty. The reason why it's very important to spend time on these things is that nowadays things are really confusing. You will hear a lot of terms AI, deep learning, ML, data science, and they are used interchangeably and they are used everywhere. You don't even know the real application of something in a particular context. So that's why it's very important to understand. For example, AI, the term itself is quite old. If you have seen Terminator, the movie, which came in 80s, you already knew the term AI. We have seen so much about it, especially in these Hollywood movies. But nowadays, when we talk about the industry, the job options, AI become very specific, very narrow down translation. So here we are going to look at what exactly AI mean, the real meaning. So AI is a higher umbrella category. It is the highest level, which essentially means that machines are making decisions like Amazon Alexa or IBM Watson. These are AI tools. It encompasses machine learning and deep learning fields. So, machine learning and deep learning, these are subfields under AI. AI in its current form is derived from math, computer science, neuroscience, artificial psychology. So, what you see today is a hybrid of all and the application side of it. That's why different industries, different companies may mean different applications or different implications when they ask or mention AI. So in healthcare industry, they may use AI for cancer detection. Now in this case, they can use something like deep learning to train the models. Whereas in a digital marketing field, they can use machine learning to come up with predictive models who do some kind of forecasting. So AI in reality is a higher umbrella category. Machine learning is the application of AI. So as I have mentioned earlier, it's a subset of AI. It uses statistical analysis to deliver results. And when I say statistical analysis, I don't mean that machine learning is 100% statistics. It means using statistical modeling in addition to modern computing power and various technologies we have today. This is the hybrid of computers and statistical modeling. I have mentioned email classification, but there are a variety of applications like recommender systems when you visit a website like Amazon, a Walmart, a Flipkart. They show you recommended products. That's coming from a machine learning model. And machine learning is probably the most widely used application of AI in today's world. Technically, deep learning is also can be considered as part of machine learning, a subset of machine learning, but the application has gone so big that it is considered as a separate branch itself. In fact, as I have mentioned in the last video, you can have dedicated job openings for deep learning where they may not even ask for things like classification or regression. They may just ask for skill set like image recognition, voice recognition, because deep learning is largely used in those kind of fields like driverless cars, where image recognition is used for training those models. And the best part about deep learning is that you don't need to define features. So, as I mentioned in the last slide, if you go back here, you can see that we need to define the features. Now, of course, there are in machine learning, there is unsupervised machine learning where we can still uh, use unlabeled data. But as far as deep learning is concerned, it's like a black box. We train our model on, let's say, images. Now in those cases, we are not going to tell model what kind of features are there in the images or what kind of feature our model should use to come up with the prediction. It's simply going to learn the feature on its own. That's why it's called black box, because we don't even know what kind of feature our model is using. We'll simply expose our model, train our model on a particular training data set. And it's very different than rest of the machine learning models, because in rest of the machine learning model we know what kind of information is being used by our model to generate a particular kind of output. And that's why I'm not going to cover deep learning in this course, because deep learning is a very vast field. But I am going to talk about neural network, ANN, which is, you can say, the biggest, which is the precursor of deep learning. I'm going to talk about that, so that if you want to take any course on deep learning later, you will know what exactly is how it functions, because deep learning is essentially advanced version of neural network. In deep learning, essentially we are trying to mimic the working of a human brain. All right, so going forward, now let's understand this difference between machine learning and deep learning in more detail. In machine learning, we need lesser data. And deep learning is very exhaustive when it comes to data. It needs tons of data. Technically, machine learning models are also less resource hungry, technical resource hungry. So if you have an average laptop, let's say with i5 or i3 and 8 GB RAM, you're good. Whereas deep learning will be really slow on that configuration. It really needs GPU because it needs to run simultaneous threads. So computationally, deep learning is very hungry. It needs more power. In machine learning, we have to define the features, whereas in deep learning, we don't. We can just, let's say, we need to build image classification for dogs. So let's say we develop a model and then we train it on a million images of dogs, and we will simply expose our data to our model. We are not going to tell our model that a dog will have 2 ears and nose and eyes, and this will be the color, this will be the size. Our model will automatically detect those figures, those features. And when you put a new image, let's say image of human, it will detect that it's not a dog. And if you put an image of a dog, it will be able to classify that image as dog. And that's why deep learning is getting so popular, because you don't need to define these features. But again, as it is very resource hungry, developing deep learning model requires more data, more resources. These are more expensive models, so they are used in very specific situations like driverless cars. Let's say you want to come up with a sales campaign, promotional sales campaign. Now in that case, you will prefer to go with something like machine learning, because you have data, you know what kind of data is there. You can use existing information, domain expertise to come up with the model. Whereas if we are talking about something like cancer detection, we have a million x-rays or some other kind of images for cancers, tumors. Now in this case, we don't know what are the very distinctive features which can be used. So we can simply use deep learning to develop a model which can automatically predict cancer. So I won't say one is better than others, because they are not. It's just that they have got different kind of applications. In this course, we are going to talk about machine learning, and I'm working on a course on deep learning which will come later. In that course, I'm going to use Python. So coming back to machine learning, as we are going to talk about machine learning in this course, there are three kind of machine learning algorithms: supervised machine learning, unsupervised, and reinforcement. Let's talk about supervised machine learning. And as I have talked about it so many times, whether you talk about machine learning or deep learning, we need some kind of data. And machine learning, and when we talk about data, if we have information about data, let's say, so if the data is labeled, which simply means that you have information about that data. Here I have talked about emails. So let's say we have a data. Let's say we have a data set with 10,000 emails. Now we know what kind of emails were spam and what kind of emails were not spam, that is ham. So we will label this information there. Let's say we use 1 for spam and 0 for not spam. So we will have a column in that data set where we will use these labels to represent this information. And when we develop our code, we already know what kind of indicator represent spam and what kind of indicator represent ham. So this is part of supervised machine learning because we already have this information. So supervised machine learning simply means that. Whereas in unsupervised machine learning, data is not labeled. So in that case, we may have a data set with emails, but we don't have this column where we have 1 and 0 for spam and ham. So I have talked about clustering here. So in clustering is an unsupervised machine learning technique where you are creating clusters, that is groups based on shared properties. So though we don't know what kind of emails are spam or ham, but we will develop a model which will look into our data and group them based on their properties. So that is unsupervised machine learning, where we cannot provide information about such labels. Reinforcement learning, the simplest example would be self-driving cars or computer-based players like chess playing bots. Basically, in these cases, we use what is called as carrot and stick approach. In carrot and stick approach, when we develop our model, we give points, which is reward, when there is a success, and we reduce points, that is if there is a failure. So essentially, we develop a model which learns by trial and error. As mentioned, these are used in self-driving cars, gaming industry, robotics, those kind of industry. So there are three kind of machine learning algorithms: supervised, unsupervised, and reinforcement. Reinforcement again is a very different than what we are going to talk about here. So in this course, we are going to cover supervised and unsupervised machine learning algorithms. So that's it for this section. We will continue in the next section. Thank you.